Good evening to one and all. In this video lecture series, we will discuss about laser beam machining process. It is one of the type of unconventional machining process. Before the video lecture series, we had already discussed about what are the advantages of unconventional machining process and what are the various different types of unconventional machining process, and also we discussed about electrochemical machining process, wire cut EDM, electrical discharge machining process, etc. In this, we will discuss about laser beam machining process. Laser. Laser means light amplification by stimulated emission of radiation. This is the 2D diagram of laser beam machining process. Here, this is the ruby rod. This is the flash tube. One end is connected to the DC power supply, and the another end is connected to the another end of the. This is the lens workpiece, partial reflective end, and that is another one is the fully reflective end. This is the Russell crystal. Before that, we are going to discuss about the quantum theory of radiation, a major principle behind the laser beam machining process. Consider an atom in the ground state or lower energy state E1. When the light radiation falls on the atom, it absorbs the photon of energy h nu and goes to the excited state E2. This is the major principle behind the laser beam machining process. Normally, the atoms in the excited state will not stay there for a long time. It comes to the ground state by emitting a photon of energy E, which is equal to h nu. Such an emission takes place by one of the following two methods. One is the spontaneous emission and the another one is the simulated emission. The first one, the excited state E2 returns to the ground state E1 by emitting their excess energy h nu spontaneously. This process is independent of external radiation as it is shown in the figure. The next one is the simulated emission. In simulated emission, a photon having energy E equal to the difference in energy between the two levels E2 and E1 stimulate an atom in the higher state to make a transition to the lower state with the creation of a second photon. There are about three types of laser: solid state laser, gas type laser, semiconducting laser. Solid state laser example is ruby laser and arc. Gas type laser, CO2 laser, helium neon laser, etc. Semiconducting laser, gallium arsenide. Synthetic ruby material is aluminum oxide. It is replaced by the chromium atoms. Chromium has a tendency to absorb green light. Next one is the ruby rod. One end is fully reflective and the another end is partially reflective. Flash tube, spiral, xenon, argon or krypton. The working of laser beam machining process. Power of about 22,000 volt is made to pass through the crystal. Light energy, the ruby rod. Chromium atoms, it is excited to the higher level. It is highly unstable. It emits photon while returned to the ground state. Emitted photons travels back and forth millions of times. The chain reaction takes place. It leads to the emission of the red light. It produces the powerful monochromatic collimated beam of light in which the waves are coherent. Different types of lasers are solid state laser, gas laser, liquid laser, etc. Solid state laser, it only provides required power level. The most commonly used solid laser is ruby laser. The xenon or argon gas present in the flash tube is fired by discharging the large capacitor through it. The electric power of 250 to 1000 watts may need this operation. This optical energy, that is light energy from the flash tube, is passed into the ruby rod. And it travels back and forth millions of times in the ruby with the help of mirror at the two ends. The emitted photons other than the axis will escape out the rod. The powerful beam of red light goes out of the partial reflective mirror at one end of the ruby rod. The high intensity converged laser beam and falls on the workpiece, melts and vaporizes the workpiece material. The advantages of laser beam are machining of non-metal is possible. Micro holes can be machined. No tool wear. Advantages in laser beam machining process: there is no direct contact between the tool and the workpiece. Hence, there is no issue of the tool wear. And machining can be done in any type of environment. Next, refractory materials can be easily worked. Easy machining of brittle, non-metallic and hard materials can also be done with the help of laser beam machining process, and it is used for welding of dissimilar metals. The extremely small holes can be drilled easily. The limitations are it is applicable only for thin sections and where a small quantity of material is removed. Control of hole size is difficult. Holes drilled may be have a slight taper formation, hence not suitable for large holes. Durability and reliability of the system is limited due to low production rate. Efficiency of system is low, and high skill operator is required in the case of laser beam machining process. And then applications: trimming of sheet metal, carbon resistors, and plastic parts. It is used for drilling small holes in the materials like tungsten, ceramics, etc. Cutting complicated profiles on thin films for making integrated circuits. Engraving patterns on suitable thin films or sheets can be made with the help of laser beam machining process. These are all some of the parts which is produced with the help of the LBM, laser beam machining process. Thank you.